What is a limit in mathematics? Let's take a look at the intuitive definition of what a limit is. Say we have some function f of x. The limit is essentially the value in which f of x approaches as it gets closer and closer to some arbitrary x value. It is as simple as it sounds. Let's take a look. Here we have this function x squared minus 1 all over x minus 1. If you notice, here at x equals 1, we have a hole, a discontinuity in our graph. Let's take a look at it algebraically. If we plug in x equals 1 into f of x, we get 0 divided by 0, which is an indeterminate form, meaning that it does not exist. Here's when limits come into play. Even though the function does not exist at x equals 1, we can find the limit as x approaches 1. If we track it from left to right, we see that as it approaches to x equals 1, the value of the function gets closer and closer to 2. And the same goes if we track it from right to left. Therefore, we say that the limit as x approaches 1 of x squared minus 1 all over x minus 1 is 2. Here we see another example. This function is 1 over x minus 1 quantity squared. This time, we see a vertical asymptote at x equals 1. If we plug in x equals 1 to the function, we get 1 divided by 0, and since we cannot divide by 0, the value of the function does not exist. But let's take a look at the limit. If we go from left to right, we see the function is approaching positive infinity as it gets closer to x equals 1, and same goes if we track right to left. Intuitively, we see this and we can say that the limit as x approaches 1 of 1 over x minus 1 quantity squared must be positive infinity. That being said, certain instructors might want you to indicate this as DNE or does not exist, because anything approaching positive or negative infinity is also classified as DNE. I just want to follow up these examples by saying we did not mathematically prove that those are the limits of the function. I just wanted you to get a visual representation of what you are doing when you actually find a limit. Finally, we see this last example of an arbitrary piecewise function. It doesn't matter what the actual function is, but we can see that there is a discontinuity in the graph. It doesn't seem to match up. Let's try to find the limit as x approaches 1. We would say that the limit as x approaches 1 from the left side, or the negative side, is 2. But let's find the limit as we approach from the right. We would say that the limit as x approaches 1 from the positive side is negative 1. This way, we see that the limit from the left side does not match the limit from the right side. Therefore, we say that we cannot conclude the limit of this function as a whole as x approaches 1. We say it does not exist. That being said, we still determine the limit from the left and from the right, which are both useful pieces of information to know. You can find the exact value of a limit of a function by using techniques such as direct substitution, factoring, multiplying by the conjugate, the squeeze theorem, and many more. These are all ideas that might come up during class or in your textbooks, but all you need to consider is that these are simply just ways with algebraically manipulating the function to artificially get rid of any holes or discontinuities. I won't be going through these methods in this video, but just remember the reason why you are doing them when you actually use them. And that's all you need to know to understand the basics of limits. If you enjoyed it, feel free to like and subscribe. Thank you for watching.